14.1 says, when a person sings, his or her vocal cords vibrate in a repetitive pattern that has the same frequency as a note that is sung. If someone sings a note B flat, which has a frequency of 466 hertz, how much time does it take that person's vocal cord to vibrate through one complete cycle? What is the angular frequency of the chords? B. When sound waves strike the eardrum, this membrane vibrates with the same frequency as the sound. The highest pitch that young humans can hear has a period of 50 microseconds. What is the angular frequency of the vibrating eardrum for this sound? Part C. When light having vibrations with an angular frequency ranging from 2.7 times 10 to the 15 radians per second to 4.7 times 10 to the 15 radians per second strikes the retina of an eye, it stimulates the receptor cells there and is perceived as visible light. What are the limits of period and frequency of this light? D. Highest frequency sound waves are used to probe the interior of the body, much as X-rays do. To detect small objects, such as tumors, a frequency around 5 megahertz is used. Was the period and angular frequency of the molecular vibration caused by this pulse of sound? Okay, so for part A, we can say that we have a frequency of 466 hertz. So period is equal to 1 all over the frequency, which equals 0.002 seconds. Part B, and let's not forget, angular frequency equals 2 pi times the frequency, which equals 2,927.97 radians per second. Okay, so then part B, the period equals 50 milliseconds or 50 times 10 to the 6 seconds. So frequency equals 1 all over the period equals 2 times 10 to the negative 8 hertz. Okay? And then angular frequency equals 2 pi times the frequency, 1.257 times 10 to the negative 7 radians per second. Okay? Part C. Angular frequency equals 2 pi times f, so f equals angular frequency divided by 2 pi. So that's going to equal, plugging stuff in, we're going to get a frequency from 4.297 times 10 to the 14 hertz to 7.48 times 10 to the 14 hertz. And then our period is 1 all over the frequency. So our period is going to be from 2.3 times 10 to the negative 15 seconds, and that goes to 1.3 times 10 to the negative 15 seconds. And then for part D, that's going to 5 megahertz equals 5 times 10 to the 6 hertz. So then our angular frequency equals 2 pi times f equals .54 radians per second. And then our period equals 1 all over the frequency. So 1 over 5 times 10 to the 6, 2.2 times 10 to the negative 7 seconds.